and welcome back to our channel where we dive deep into the fascinating world of organic chemistry. Today we are going to unravel the secrets behind IUPAC naming of unsaturated hydrocarbons, specifically alkenes and alkynes. So if you have ever wondered how these complex molecules are named, you are in the right place. In this video, we will be focusing on IUPAC naming of alkenes and alkynes, two types of unsaturated hydrocarbons that are crucial building blocks in organic chemistry. Here are the rules for naming unsaturated aliphatic hydrocarbons. Aliphatic hydrocarbons are a class of organic compounds in which carbon atoms are arranged in straight chain or branched chains. Okay, so here is the first rule, that is the longest chain rule. In unsaturated hydrocarbons, selection of the parent chain is more important. Okay, so here is the rule. In the case of unsaturated hydrocarbons, the longest chain of carbon atoms is so selected as to include the double bond or triple bond even if it is not the actual longest chain of carbon atoms. That means the longest chain must include double or triple bond. Okay. Here is an example. This is an organic compound in which there is a double bond. In this organic compound, in order to provide IUPAC name for this compound, first we have to select the longest chain in it. And this one is an unsaturated hydrocarbon, and we have to select the longest chain of carbon atoms in such a way that it must include double or triple bond. See here. This is the actual longest chain and it contains 8 carbon atoms. But this longest chain of carbon atoms doesn't have included double bond. So this one is the wrong selection of longest chain, and we have to go for this one because it has included the double bond. So this is the correct selection of longest chain, and this one is the wrong selection. Okay. When more than one double or triple bond is present in the molecule, the longest chain of carbon atoms is so selected that it includes maximum number of such bonds even if it is not the actual longest chain. See, for example, this is an organic compound and it contains 2 double bonds. And in this case, selection of longest chain is more important. If I select this as the longest chain of carbon atoms, it includes only one double bond. You see here. And this one is the actual longest chain because it contains 7 carbon atoms. But in this case, this is the wrong selection. Why? Because it includes only one double bond. Instead, if I select this as the longest chain of carbon atoms, isn't it? Then it includes 2 double bonds. That means the selection of the longest chain should include maximum number of double or triple bonds. So this one is the correct selection of the parent chain, and this one is the wrong selection. A primary suffix is added to the root word to indicate the presence of double or triple bond in the parent chain. See here, for one double bond, root word plus locant plus ENE, in. If only one double bond is there, this is the IUPAC naming structure. Root word plus locant. Locant means the number that locates the position of the double bond is known as locant. And for one triple bond, root word plus locant plus YNE, ine. In the case of parent chain contain two or more double bonds, two or more triple bonds, the prefixes di, tri, tetra, etc. are used before primary suffix. See here, for two double bonds, root word plus locant plus di-ine. If two double bonds are there. If two triple bonds are there, root word plus locant plus di-ine. You can see here, when there are two double bonds in the molecule, the IUPAC name is alk plus adiene, that is alkadiene. Similarly, when there are three double bonds in the molecule, the IUPAC name is alk plus atriene, that is alkatriene. In the same way, when there are two triple bonds in the molecule, the IUPAC name is alk plus adiene, alkadiene. When there are three triple bonds in the molecule, the IUPAC name is alk plus atriene, alkatriene. The second rule is numbering of carbon atoms. After selection of the longest chain of carbon atoms in unsaturated hydrocarbons, the carbon chain is numbered. Here is the rule for numbering. The parent carbon chain is numbered in a manner so as to give lowest number to that carbon atom linked by double or triple bond, even if it violates the rules of saturated hydrocarbons. You can better understand by this example. So this is an organic compound containing one double bond here. So this is the longest chain of carbon atom. That means this is the parent chain. This parent chain is numbered either from left to right or from right to left. See here. From right to left also I am numbering the carbon atoms in the chain. And which way of numbering is correct? In order to know that, we have to keep one thing in mind. The carbon atom that is linked by double or triple bond should get the lowest possible number, even though it violates the rules of saturated hydrocarbon. That means we have to give the priority to the double or triple bonds, not for the substituents. Okay, so if numbering is done from left to right, second carbon atom is linked to the double bond. Okay, so if numbering is done from right to left, the double bond has been attached to the fifth carbon atom. So the numbering from right to left is the wrong way of numbering, and this one is the correct numbering. Okay, that means keeping the substituents aside, we have to give the priority to the double and triple bonds while numbering the carbon chain. Okay, here are some worked out examples. Write the IUPAC names of the following compounds. Problem number 1. Okay, this is an organic compound to which we have to provide IUPAC name. Solution, take down this, and first we have to select the longest chain of carbon atoms. Okay, so if I select this as the longest chain of carbon atoms, it does not include double bond. So we have to select this as the longest chain of carbon atoms, which includes double bond. So after selection of the longest chain of carbon atoms, we have to give the numbers, the carbon atoms in that chain. Here I am giving numbering from right to left. That is the multiple bond, the position of the multiple bond should get lowest possible number. Okay, so if numbering is done from right to left, first carbon is containing double bond. If numbering is done from left to right, then sixth carbon atom will contain double bond. So this is the correct way of numbering. And this group is called propyl group. 3 carbon atoms are there and 7 hydrogen atoms are there. C3H7 means propyl group, substituent. So in this carbon chain, 7 carbon atoms are there. The root word is hept. Primary suffix, because double bond is there, here you can see the primary suffix indicates the nature of saturation. If double bonds are there, we have to go for ENE, ene. Primary suffix is ene, and in this compound only carbon and hydrogen atoms are there. That means only hydrocarbons are there. For that reason, in case of hydrocarbons, the functional group is E. Next, primary prefix won't come. It will come only for cyclic compounds. Next, secondary prefixes are nothing but substituents. Here, one side chain is there. It is called substituent. It is propyl, C3H7 propyl. So the name of this compound is 3-propyl hept 1-ene. 3-propyl hept 1-ene. And we should remember one thing here, the position of the multiple bond, that is double or triple bond, is placed immediately before suffix ene or yne. For that reason, I have placed one before ene here. Okay. Next, problem number 2. Solution. See here, we have to select the longest chain of carbon atoms at first. The actual longest chain is this one. If I select this as the longest chain, it contains 1, 2, 3, 4, 5, 6, 7. But it is included only one double bond. So we have to select the parent chain in such a way that it includes more number of double bonds or triple bonds. For that reason, I am going to select this as the longest chain of carbon atoms. So this one is the parent chain. And to this parent chain, numbering can be done either from left to right or from right to left. First, I am numbering from left to right. Next, I will number from right to left also. So which way of numbering is correct? In order to know that, I am going to use lowest set of locants rule. So from left to right, you can see here, locants means here we have to go for double bonds. That is the position of the carbon atom to which double bonds or triple bonds are attached are called locants. So from left to right, if numbering is done from left to right, the locants are, see here, second carbon atom and fifth carbon atom are attached double bonds. So 2, 5 are the locants. From right to left, 1 and 4 are the locants. That is, the first carbon atom and the fourth carbon atom have been attached double bonds. And we have to compare these sets term by term. So here at the first point of difference, 1 is less than 2. That means you no need to compare the remaining terms. So at the first point of difference, 1 is less than 2 means set to 2. That is, numbering from right to left is the correct way of numbering. So this one is the wrong way of numbering. This is the correct way of numbering. And the root word is hex, primary suffix "-ine" because double bonds are there. Secondary suffix is "-e". Okay. And here this is called as the substituent propyl group C3H7. Okay. And here two double bonds are there in this chain. So when two double bonds are there, the IUPAC name is alk plus adiene, alkadiene. That means hexa. We have to attach A to hex root word. So the name of this compound is 3-propyl. Okay, 1, 4, 3-propyl hexa 1, 4 diene. 3-propyl hexa 1, 4 diene. Okay. Next, problem number 3. Solution. So this is the longest chain of carbon atoms including double bond, and we have to number the carbon atoms in this longest chain either from left to right or from right to left. So which way of numbering is correct? In order to know that, we should know double bonds or triple bonds are given more important than substituents. These are the substituents. That is, the carbon atoms bearing multiple bonds should get the lowest number possible. So here I am numbering the chain from left to right and from right to left also. So from left to right, second carbon atom is attached double bond. From right to left, fifth carbon atom is attached double bond. So right to left numbering is the wrong way of numbering. So let us remove that. Now these two are the substituents, methyl groups. So the root word, 7 carbon atoms are there. The root word is hept, primary suffix en because double bond is there. Secondary suffix is e, and secondary prefix methyl. 2 methyl groups are there attached to 4th and 6th carbon atoms. So the IUPAC name of this compound is 4, 6 dimethyl hept-2-ene. 4, 6 dimethyl hept-2-ene. Okay. Next example 4. This is an organic compound containing triple bond, alkyne. Okay. So we have to give the IUPAC name for this. This is the given compound. First we have to select the longest chain of carbon atoms. You can select either this as the longest chain or this as the longest chain. Here I am selecting the straight chain as the longest chain of carbon atoms, and we have to give the numbering from left to right so that the carbon atom bearing the triple bond gets the lowest possible number. Because multiple bonds, that is triple or double bonds, are given priority over substituents. Okay. Now the root word is hex. Primary suffix, it contains triple bond. Triple bond means yn. Secondary suffix e, and one substituent is there, secondary prefix is there, that is methyl group. And the name of this organic compound is, methyl group is attached to the fifth carbon atom. So 5-methyl hex 2-ine. 5-methyl hex 2-ine, YNA. Okay. Next, problem number 5. So this is an organic compound to which IUPAC name is to be given and solution. Okay. So in this, any of the chain you can select as the parent chain. Here I am selecting this as the parent chain. 1, 2, 3, 4. I am numbering from left to right, isn't it? So in this chain, 4 carbon atoms are there. The root word is but. Primary suffix is en. Secondary suffix is e. And second and third carbon atoms are bearing 2 substituents, methyl groups. Okay. So 2, 3 dimethyl but-2-ene. 2, 3 dimethyl but-2-ene, because second carbon atom is attached one double bond. So this is the IUPAC name of the given compound. Next, problem number 6. This is an organic compound. We have to give the IUPAC name for this. So this is the longest chain of carbon atoms I am selecting, and numbering can be done in either way, that is from left to right and from right to left also. So which way of numbering is correct, I will determine later by using a rule called lowest set of locants rule. I am using here. Okay. Lowest set of locants rule, you see here, set 1 locants are, if we consider the numbering from left to right, then third and fifth carbon atoms are bearing double bonds. And if we consider the numbering from right to left, first and third carbon atoms are attached double bonds. Set 2 locants are 1, 3. So these two sets we have to compare term by term. Now at the first point of difference, 1 is less than 3. It means set 2, that is right to left numbering, is the correct way of numbering, and this one is the wrong way of numbering. So you remove that numbering. Next, the root word is hex. Primary suffix is en. Secondary suffix is e. And secondary prefixes, one substituent methyl group is attached to the fifth carbon atom here. So the name of this compound is, you see here, alk plus a diene, alkadiene. Why? Because here 2 double bonds are there. So alka, that is hexa. Okay. So 5-methyl hexa. Okay. 1, 3 diene. So this is the IUPAC name of this organic compound 5-methyl hexa 1,3 diene. Next, problem number 7. Here is the solution. In this organic compound there are 2 triple bonds. So numbering can be done in either ways. So here I am numbering the carbon atoms in this chain from left to right. 1, 2, 3, 4, 5. So the root word is pent, primary suffix yn, secondary suffix e, and one substituent, that is secondary prefix, is there, and it is attached to the third carbon atom. It is methyl group, and there are 2 triple bonds. First carbon atom and the fourth carbon atoms are bearing triple bonds. So alk plus a diene, alka diene. Okay, so the name of this compound is, the root word will become as penta, alka, here penta. So 3-methyl penta 1,4 diene. 3-methyl penta 1,4 diene. Okay. Next, problem number 8. This is an organic compound containing 2 double bonds, is to be given IUPAC name. Solution. In this organic compound, first we have to select the longest chain of carbon atoms containing maximum number of multiple bonds. So this one is the actual longest chain, but if we select this as the longest chain of carbon atoms, it includes only one double bond. Instead, if we select this as the longest chain of carbon atoms, then it includes 2 double bonds. So in the case of unsaturated hydrocarbons, we have to select the longest chain of carbon atoms in such a way that it includes maximum number of double or triple bonds. So here I am selecting this as the longest chain of carbon atoms, and the numbering can be done either from top to bottom or from bottom to top. Which way of numbering is correct? To know that, I am going to use lowest set of locants rule. So from top to bottom, the locants are 1, 4. Set 1 top to bottom, the locants are 1, 4. Set 2 from bottom to top, the locants are 2, 5. That is, second carbon atom and the fifth carbon atoms are attached double bonds. And this is one substituent. 1, 2, 3, 4 carbon atoms are there. It is butyl. Butyl C4. Okay. 3 plus 2, 5 plus 4, 9. C4H9. So it is butyl group. So we have to compare the which way of numbering is correct. In order to know that, we have to compare these two sets, set 1 and set 2 locants, term by term. Here 1 is less than 2, so that set 1 is the correct way of numbering. So this one is the wrong one. Root word is hex, primary suffix en, secondary suffix e. Okay. Now This is butyl group substituent. So alk plus a diene, alkadiene, because two double bonds are there. So the name of this compound, organic compound, is fourth carbon atom is bearing one substituent butyl, that is 4 butyl hexa, alka hexa 1 comma 4 diene, 4 butyl hexa 1 comma 4 diene. Okay. Next, problem number 9. Solution. This is an organic compound containing 3 double bonds, 1, 2, 3. So this is the longest chain of carbon atoms. We have to give the numbering either from left to right or from right to left. So which way of the numbering is correct, I will determine later by using the lowest set of locants rule. See here, from left to right, lowest set of locants rule, set 1 locants are 1, 3, 5. That is first carbon atom, third carbon atom and the fifth carbon atoms are bearing double bonds. Similarly, set 2 locants are 1, 3, 5. Okay, so here double bonds are positioning at the same numberings. That is from left to right and from right to left, the locants are same. At that time we have to look for the substituent. That means the substituents should be given lowest possible number. So here the substituent is attached to third carbon atom if the numbering is done from left to right. So we have to choose the left to right numbering, and this one is the wrong one. Okay. Next root word is hex, primary suffix double bonds are there, en, secondary suffix e. Okay. Next, secondary prefixes, that is only one secondary prefix, that is one substituent is there, that is bromine. Okay. So here alk plus a triene, alkatriene. Why? Because 3 double bonds are there. So here hexa, alka, here root word becomes as alka, hexa. So 3 bromo hexa 1 comma 3 comma 5 triene. 3 bromo hexa 1 comma 3 comma 5 triene. Okay. Next, 10th problem. Solution. So we have to give the numbering from left to right only. Here 1, 2, 3, 4, 5. Root word is pent. Primary suffix is yn, secondary suffix is e, and one substituent, that is chlorine, is there. Okay. So 4 chloro pent 2 ine, 4 chloro pent 2 ine. Okay. So let us learn some more complicated, that is complex unsaturated hydrocarbons in the next coming video. Okay. Thank you.